Hello everyone, my name is Sundara Swani Didde. My teammate Jeet and I are here to present about fraud detection and credit card transactions. So let's talk about credit cards. So credit cards are financial tools that allows you to borrow funds up to certain limits to make purchases. To promise to repay the borrower the amount later. So the key features are credit card limit, which is done by knowing your credit score. So the higher your credit score, the more the limit. And then when you have minimum payments every month that you have to do so that you have your credit card with you. And then let's talk about the vulnerabilities. So we have identity theft. So if once your credit card is stolen, then your money is going to be stolen because it's in the wrong hands. Next is fraudulent activities. So credit card details can be stolen and used for unauthorized transactions, leading to financial losses. We also have phishing and social engineering, where they could make sure by emails and messages that they steal your information. We also have data breaches. So if a company does go into a data breach and they have your credit card details, then trust me, my friend, your data is gone. So yeah, money is gone. We have skimming devices, so let's not say that ATMs are safe because they could actually have a copy of your credit card with those skimming devices. So let's go a little bit on the introduction. Our project is mainly to focus on these vulnerabilities. So we studied a lot of papers regarding those vulnerabilities and how to identify them. So because there's a lot of transactions, there's a very little amount of fraudulent transactions. So to identify them, we're going to divide the data set into legitimate and fraud and understand from there.
So I think few informations that we have in the internet. There are a lot of other credit card fraud which we overtook. These are some headlines from some newspaper. These are the main motivation behind our projects. Uh, with the increase in the technology, there is a huge number of digital payments and detecting the credit. We have to keep up with the technology. So detecting credit card frauds is very essential if the person's behavior is legitimate or not. The main objective is to find the best model which can identify this transaction and reduce the factors of identifying such transactions. The scope behind is the fraud in credit card transaction is evolving as electronic payment system has also evolved with the time. And with increase in reliance on electronic payments, the number of credit card transactions has grown exponentially. And this has caused a lot of vulnerabilities. Many transactions are legitimate, thus there is not any balance data set present anywhere. This can also be resolved by using the techniques like oversampling, undersampling, or smart.
So yeah, let's talk about the data set. So the data set is transactions made by credit cards in the in the year September of 2013. So it only has 490 frauds out of 284,807 transactions. That is a large number. So that is like 0.172% of the transactions that are fraud. So to identify such transactions would be tough. So I'd give a little description about the transactions in the data set. We have V1 to V28, which is done using PCI analysis because we do not want to have personal information of the credit card holders. That would lead to a lot of problems. We don't need problems. So the only important information other than V1 to V28 is time, amount, and class. So right now we are focusing on amount and class, and over here the class is legitimate class and fraud class to understand the spending behavior. So we did some exploratory data analysis, and then we found out that there is very less amount of fraudulent transactions, and we need to do a lot of sampling. So with this, we did some sampling techniques to understand which is the best data set, and we did a lot of different samplings. Yeah. So the first is oversampling. It involves increasing the number of instances of the minority class, which is the fraudulent transactions over here, 492, by randomly duplicating the minority class, the fraudulent classes. Next is undersampling. like how we're randomly increasing the fraudulent classes, over here we're gonna decrease the number of legitimate classes by removing them. Next is SMART.
So SMART is an abbreviation used for synthetic minority oversampling technique. It works similar to the oversampling, but it draws a line between the example in the feature space and a new sample at a point along that line. So we'll talk about the classifiers that we have used in our project. There are six classifiers. I would start with the logical regression classifier. As we know, our data set is mainly binary, as the data is in zeros and ones, legitimate or fraud. So, by logistic regression plays a crucial role in the binary classification task. It finds the best fit parameters for the non-linear function called simoid. It uses a linear combination of features and feed it to the function. This tells how likely a new data point would belong to the legitimate class or the fraud class. Next is the K nearest neighbor, also known as KNN classifier. It is an instance-based learning where classification is carried out based on some similarity measures. It uses three different kinds of distance functions. The main function that we have used in this project is Euclidean distance. For every data point in the data set, the Euclidean distance is calculated between those 2 points. The distance are then put in the k items order, and the lowest distance between those input points is selected. The third one is naive-based classifier. It is more of a statistical approach based on bias theory, which uses the decision which has the highest probability to occur. The bias probability estimates unknown probabilities with the help of the known probabilities. The classifier is based on conditional probability, like
So next is the random forest classifier. So we do multiple decision trees where each tree is trained on a random subset, then the training set, in the training set. So now we give importance to different features equally. So this reduces overfitting. So it makes minimal assumptions about the underlying distribution of data. And next is the decision tree classifier. So it is a nonlinear model that recursively splits data into feature conditions, leading to a tree-like structure. Each internal node represents a decision based on a feature. So each branch represents the outcome of that decision. So this also doesn't make any underlying assumptions of the data. Yeah. So XGBoost classifier is a robust ensemble model, which is scalable, and so technically it just takes all the multiple peak learners and updates it at every step and corrects it at every step. With this, we don't have any overfitting problems, and it's very good. And it uses L1 and L2 regularization for the overfitting.
so. Like you can see, these are the results that we have obtained on the four data distributions that we had. The unsampled, undersampled, um, oversampled, and the small. And the four results, we can clearly see that random forest outperformed the XG boost. And over here, I'll just show you the complete analysis graph of the undersampled data set. The graph depicts each model's accuracy, precision, recall, specificity, and MCCs. These were the metrics that we used to check the performance of them. The greater the value of each metric, the better the model performance is. According to the graph, random forest and XGBoost appears to outperform the other models, like we can clearly see, except the specificity, where KNN performs slightly better than them. But like among this six classified tested, we know that Gaussian nice base model was not working that great. Just to keep in mind, the differences were very minor. It wasn't that great since the differences on a scale of 0.9 to 0.95. So I don't think it's a very big difference, but I would prefer now to use a random forest and XGBoost over the other four models after the analysis.
So in conclusion, we used 6 classified models based on machine learning, and then we found out the outcomes on 4 different types of data set. So yeah, this is what we understood, and this is what I wanted to say. Thank you. And these are some of the references that we took care of and read during the process of understanding this. Thank you.
Thank you.